I mean, you just go into the file.
Yeah, so here,
it's got a cargo.com.
close the command window. Let's start command window. Yes. Right. All right. Great.
For documents. I mean, it doesn't. It just matters where you put the file. The laser one. It's got a cargo.toml that I can build it if I want. So with cargo.build. If you want to build the release, which has got all the optimizations, you do -- release. If you want to just immediately run it as soon as it compiles, you just do run. And that's pretty much it. If there's any other commands, you just do cargo help. It tells you. You can clean if you want to completely recompile it new.
Gotcha.
You can generate the documentation for the thing.
Gotcha.
You can make a.
So you just use cargo. How you run this one? Cargo build, right?
It's just cargo. It's the main executable, but then you can give it subcommands. Like if I wanted to make a new Rust project, I just go cargo new, and then I can just give it whatever name I want. So I can be like new project. And then if it makes a binary.
Gotcha.
If you wanted to do a library, you could do -- new.
That's awesome. Great. For this is binary, right?
Yeah, it's a binary application.
That's awesome.
That's why it only has a main.rs.
Okay.
If it has a lib, it would be different.
This is actually new app, right? Already new app, right? This already built it.
Yeah, it already built this.
Okay.
I should find logs. Yeah, it's working. It's just a matter of
the data.
Yeah, the data's not coming across right now, or it's just all zeros.
Gotcha. So what's the relationship between the cargo versus the Rust app?
Rust app manages like your tool chain. Cargo manages like your projects.
The dependency, right? Rust app dependency, right?
Rust app is like your compiler, like all your compilers. So maybe you want to use the nightly compiler. You tell Rust app, hey, let's say Rust app. I think it's you can install the nightly. I'm gonna check the commands. So it's easy. You just check the commands that you need to do. And this is just for managing like the version of the Rust compiler that you're using. So if I want to say install, I guess it's probably going to be.
So you can use Rust app install the third-party library,
right? Not install third-party libraries. It's to install a different Rust toolchain. So like Rust, you want to use the nightly Rust compiler, which just means like you're getting like the bleeding edge of like what a lot of the new features are.
You actually almost similar to Condo. You install different Python version. Version of Python.
That's kind of like you can kind of.
So you use Rust app to manage different version of Rust you want to use.
Right. Yes.
So how you install third-party module?
Like a third-party application or like a third-party library.
Library.
I mean, I can just show you what I did in Laser. So let's see if I can. Kill it. So if we just go here, I don't know if they have them. Okay, there's not them.
Okay.
All right. Well, let me just go to the file folder first.
Okay.
I gotta open it with whatever this uses. So whenever you want to like. This is the cargo.toml file. This just means that these are third-party app. Like, these are libraries essentially that you're able to use inside of it. Like eGUI offers the GUI that I'm using.
That's awesome. Yeah. How you just install one command line, right? It should be right.
Yeah, I mean you just put it here and it's now a dependency in your.
It's automatically managed.
Yeah, it's automatically managed. You just got to put the version that you want.
I see. Wow, this is even better than years ago, like NPM. You know NPM, right?
Yeah.
Yeah, so NPM, even PEEP is better actually. It's more autonomous actually.
Yeah, and you can put feature flags because a lot of these.
Yeah, that's why Rust they need a new language.
And then
right.
Whenever you want to use it, you can just see. I think main.rs.
We already installed the library.
Well, they're not installed immediately, and as soon as you start building, they'll be put in the target. They'll go release, and you can see dependencies.
So it is really like a compile, not only fetch dependency in the compile time.
Yeah, the thing
is
not
fetch the dependency.
Rust Analyzer will go ahead and it'll like fetch a bunch of the dependencies to do like static analysis. So it will fetch a good majority of the dependencies already for you whenever you do when you just use Rust.
But you never worry about how to install dependency.
Yeah, you never have to really worry about it at all. You just say, hey, I want to add this to you can add it to your cargo.toml file, or there's also a thing through Cargo where you can just go like, if I want to add a dependency, I could just do cargo add, and then I can just do the dependency like if I want.
Dependency name and version.
Yeah, or you don't have to put a version. It'll do the latest version.
It's always latest version.
Yeah, I mean.
But if there's a
you
conflict,
could-
how you can manage?
Yeah, if there's a conflict, it'll just do the next best thing.
Actually, it's autonomous.
Yeah.
Oh wow! So this is awesome.
And a lot of them actually like they don't do conflicts like that. If one person needs, like they will vendor two different versions. So if one version of your dependencies need a different version, it'll put both. It's kind of like bloat because it'll have two different versions added, but it does it to maintain like it doesn't want to like cause undefined behavior because like you don't know what could be changed between versions. So it'll just vendor both versions.
Both versions?
Yeah, like so if there's a
Both
dependency,
versions, how you can manage which one to use?
it knows like it'll link it. The linking is done a little bit different with Rust.
Oh, okay. So it's automatically linked the correct version, I think.
Yeah, it'll link the correct version for each like dependency.
I see. So the idea is that they try to make things autonomous, not something you have to worry about as a programmer. Wow, that is awesome. This is cool.
And this is kind of where I use stuff from the library like GUI plot. Some of this is mine.
Yeah, this actually similar to Python. Similar idea though.
Yeah.
So here, so where's the dependency? The file. One more time. Go to file browser. I want to see where dependency file is. Which dependency file?
This file is this file right here, cargo.toml.
Oh, that's one.
Manages all your dependencies.
So you have to you typically write down use this text editor or you use a cargo add. Which one? Command line or
I use the command line unless like sometimes you need to come in here and like specify exactly a version.
Yeah. It's just a bit tricky sometimes, right?
Yeah.
So the manager version.
But I mean, most times like I don't really have to do anything. I just do cargo add, and then you can specify features by like so if there's a crate that has a specific feature you want, so like let's say if I just say let's just do one I already have. Saturday, I can do capital F to specify features and just say derive.
Oh.
And it'll add it. It tells you the features that.
Wow, that's pretty convenient. That's super awesome. I like it. Yeah. So this is yeah. So can you explain a little bit about the coding, the logic, the code? Yes.
Okay. I mean, it's really all you're doing is you've got a connection. There's optionally a connection, so it's either there's a connection or there's not a connection.
Right.
If there is a connection, basically there's a channel that I'm listening to saying, hey, let's see if I can go to where I have the serial logic. Basically, the worker the entire time will try to connect, and then let's see. Okay, that's not the worker. Hold on. This is the worker. But yeah, there's messages, which are the things that are being sent from the main thread to the worker thread, and there's events, like it tells you if it disconnected or if it erred. So we just create this. We talk to the serial port. We create a log file. We spin up the channel, give it back to the host. This just spawns a new thread, essentially here. That's just looping, so seeing if I got a message to either pause, resume, or disconnect. If I didn't get a message, which this is like it just selects whichever one to come first.
Yes.
If I'm not running, like if I've been paused, I'm just gonna sit here and kind of just sleep for a second and just keep waiting for another message to come through. And then I have a way of decoding the incoming frame, so I try to frame all the stuff coming from the the serial port. And then you just kind of give the illusion that you're not saving all the data. You only save like the 60 and then just pop from the front. It's kind of like a vector key. You're reading into the front and you're popping from the back to kind of make it look like the line is like being read. I mean, it is being read in real time. It's just getting rid of data points that are older than 60.
Okay.
And yeah, I mean, that's much for that logic. But other than that, you're just there's also in here I've got like a mutex where you can see I kind of have like this different scope where I'm basically calling it's kind of hard to explain without hoping that the person knows what a arc and read write lock, which is just like kind of like a mutex. So arc is just you have shared
because your threads.
Yeah, it's between threads, so you have to have some type of mutex because if there's two threads racing for something, then
lock essentially you'll signal lock.
Yeah, so the idea is that you just call it a data write. I put it in the scope because you don't want to you want it to be able to drop as soon as possible. If I had kept it in this whole scope down to the request repaint, there's actually some time where it would be still being like captured or like held when it didn't need to be.
Right.
So whenever this is where you can actually send the messages. Let's see. or this is actually just a wrapper around the channel. So like it'll try to receive a message and it'll see if the event was either disconnected or errored. This is like actually popping up this pops up like the little things on the top right whenever you connect or whatever.
That makes sense.
This is doing all the plots, so it just reads the data, iterates over it, tries to match with whatever plot data that they want, collects it, and then just uses the plot GUI thing to make it easy.
That's right.
Let's see, I think I have the main here. And this is just, I mean, you have to like look at GUI because this is kind of like, I know it's very long, but this is how they want to do it. But basically, I just iterate over the available ports. For each port, I just make a new thing. So if I click on it, I make a file dialog, and then I start the serial thing.
Right.
And yeah, I mean, other than that, that's just, yeah, I mean, if you click, yeah, you can see where if I use images here, so it's kind of hard to see, but I have like the pause, and you can send the message pause.
Wow.
If it's resume, you can send the message resume to the worker thread.
Wow.
And that's just kind of the idea.
That's super cool. I like it. Yeah. So that's pretty much the mainly two files, right? One serial, another worker, right?
Yeah, there's a couple files actually, because I mean, I made like my own bi-directional channel.
And
then
what about your channel do?
It's just like I wanted to. I didn't want to have to do a bunch of boilerplate. I wanted to basically spawn this, and it'll talk to. It has a channel that can. Both of them have a channel that they can send and receive. So like. We give each one a sender and a receiver, so they can also listen to what the other person says, and they can also send to the other person.
Okay.
It's just like like I said, it's bi-directional communication. They can both talk to each other. They can both hear each other.
You mean the threads?
Yeah, the threads. They can talk to each other. They can like talk back and forth if they want to.
Oh wow.
And this codec stuff is it just parses out whatever. In this case, the way that they do it is there's like spaces in between all the data, so I would just look for the next space and try to parse out whatever it's supposed to be. In this case, they're all I-64s. So I just parse it out.
Parser, you they are binary files or parser what? Or binary to
this is for the serial port, and no, it's just sent like a string, so you have to just read it. You just kind of like look for the next space, essentially.
What's the input? What's the output between the parser, the codec?
The codec, it just takes like a byte stream, and it tries yeah, it's a bunch of bytes coming from the serial port. It'll try to basically, it'll say I want the next field, and if it can't fill this up, it'll just say that it's not possible. And really what it will actually do is it'll say I need more bytes. So then it'll get the decoder thing will give us more bytes, and then we try to make an item, and if it can't make an item, it gets more bytes. But then if we try to make an item and it fails at making the item because the data is malformed, it'll error. But if it can make the item, it'll do it as fast as it can. So it's kind of like optimized, where it's just like if I don't have enough data, okay, request more data. If it's errored, okay, tell them I errored and like kill the connection. And if it's perfectly fine, it'll just whatever it doesn't use, it'll just chop off and give it to the bytes the next time, and it'll be reused.
So it's convert bytes to integer, all right? Integer?
Yeah. You just say it like that.
Oh, wow. So we have codec, we have bi-direction, we have worker, and we have serial, right?
Yeah.
We have serial file located. In there. We have serial. So go click serial folder, please. This serial, right? Serial.
Yeah,
yes,
this
yes.
is the one I was talking about earlier.
Where bi-direction worker located?
The binder. I mean, this is the channel right
Yeah,
here.
yeah, that
this
makes sense.
This is the channel. It can
Gotcha.
it can send a message and it can receive events. I put the send first, then the
Send a message to where?
the worker thread.
Send to work thread, right? And then event is what it received from the thread, right?
Yeah, it can receive events.
I could receive events.
That's the idea. Like a message is something that you send to something, and an event is what you receive.
Send and receive, right?
Yeah.
The serial is this struct is coordinating between the threads, right?
Yeah, serial is just it holds the channel that talks to the worker thread. It's not. It doesn't hold the thread. It's not in another thread. It does hold the data that you're plotting.
How many threads are you using?
2. There's only a main thread and there's a worker thread.
The main thread. What's different between main threads and worker threads?
The main thread is just the thread that your main function's being ran on. It's
right. So worker thread do what purpose here?
The worker thread is the one that's reading the serial port and updating the data.
So actually, what the hard work done by this like
The worker thread, yeah. Because
worker thread.
the main thread is the one that needs to be drawing the GUI. So
The most of the GUI things.
yes.
The data is work thread. The GUI thing is really the main thread.
Yeah.
That's beautiful. That's good. I'm not expecting when you do this like a threading, but I think you think deeper should be make sense. Otherwise, it can blocking.
Yeah.
No, it's not. It's not blocking anymore.
Yeah.
Oh wow, that's a good. You're bidirectional, right? You have a couple of different library. You have bidirectional library, codec library, right?
Yeah.
Mode is library in Rust, right?
What was it?
Mode is a library or
Mode?
is it mode MOD?
Mod. Oh, mod.
Mod.
It's a keyword. It just means like it's just like a namespace and keyword. It's kind of like namespace in C++.
Ah,
like
namespace.
It's like you're importing a namespace. Really, what it is it's because this is a serial is the main file. Like so, like you can see, it's serial's named here, but there's also a folder named serial. So it's really the thing that you have to import. All the files in here need to be imported by serial. So it's saying like this is like the visibility. It's kind of like the visibility marker. So if I say pubmod, it'd mean that like the entire library can access these files. But if it's just saying mod, it just means only serial can access it.
Only serial within the folder can access.
Yeah, only serial can access it.
Because
Because it's not public. If I put pub, then yes, the entire like the main file would have access to bidirectional, but it doesn't.
yeah, that's probably not good. So you want to control visibility.
Yeah, I just try to keep it modularized so I don't have to worry about too much stuff and like put associated things with associated objects.
So what input RMPL implementation? RMPL.
Impl, it just means like the implementation for this struct.
Implementation.
Yeah. So serial implements new, it implements is disconnected, and implements show.
Which one, sorry?
It implements is disconnected and implements show. So like show the plot of the current serial readings. It just takes all the readings and makes a plot.
Gotcha.
All right. I gotta get to class. I got like 1 minute. It's at 10:20.
Alrighty, sure. Thank you.